Hey everyone, welcome back to another episode of the Weekly Coder. This week we're going to pick up from where we left off with our 2048 clone. This will be part 6. So, with our previous video, what we did in part 5, we basically have a fully functional, well, almost fully functional. It works, it does what it's supposed to. But assume we get into a situation like I'm gonna have to get to a game over situation. Anyways, so a situation. Apparently, if you play this in randomly, you can play forever. Alright, this is it. Okay, so here we are. And at this point, we shouldn't really be able to do anything else, which we really aren't, but our game doesn't know that it's game over yet. It has no clue. It still allows us to press buttons, and everything's just kind of still going. What we need to do is we need to create a method that will detect whether or not the game is over. Okay? So what would a method like that look like, you think? If we needed to just kind of think of it and say, well, alright, so we're this far into the code, and we want to check to see if the player has any moves left, because that's when we know the game is over, right? So does the player have any moves left? So what's the best way to do that? Well, since we have our tiles, right, we can, and we know what our grid size is, we can create a for loop that iterates over all the tiles. It can then check the tiles adjacent to the tile. So like 8, for instance, in the lower left corner, we can check if 32 or 16 can be moved into the 8 by pressing the left or the down button. In this case, we can't, so that is not a valid move. Then we check 32. Can we move 8 into 32? Can we move 8 into 32 from the top? Can we move 4 into 32? No. And we check the 4. 32 to 4, 16 to 4, 2 to 4. None of these work. And we check 2. 4, 8. Nothing. So that whole row doesn't work. So then we check the next row, and the next row, and the next row. And if we get to a situation where we've checked every single tile to see if it can match with any other tile, and we come back with 0, then we know we're in a game over state. Okay, so let's get into the code. Let's look and see how we would do this. So let's go to the scripts folder and open up our game class. And we are going to create this method right below check user input. So what we're going to do though is we're going to make our method return a Boolean value, so a true or false, yes or no, and we're going to call this check game over. And we don't really have to pass any parameters to it, so it's fine just like this. So what we're going to do is we're going to say first we're going to check if the transform.child count is less than grid width times grid height, then we return false. Okay, so what does this do? This is a very quick check to see if we've got enough objects to even check to see if it's game over. So what we're doing here is we're saying, hey, do we even have enough tiles in the parent? So basically on the grid, do we have enough tiles on the grid to represent a game over? So by that we mean we have to have 4 times 4, which is 16, right? So we're doing grid width times grid height, which is 4 times 4, which is 16. And if we have less than 16 tiles, meaning the child count, and that's one of the reasons we're setting our tiles as children of that parent, because now we can just check to see how many children that parent has. And the only children of that parent, which is our transform, our game class, are only the tiles. So if we get a child count of our transform, that's going to return back how many tiles we have on the board currently. So if we've got 15 tiles, then we have at least one move left. So we're just going to return false because obviously the game is not over, right? So now for the fun part, we're going to create a for loop. We're going to use integer x equals 0, and x is less than grid width. Oops, messed that one up. And x plus plus. Alright, and then we're going to do the same thing for y. For int y equals 0, y is less than grid height, y plus plus. Okay, so this should be nothing new to you. We're just taking a for loop. We're iterating over the x axis, and for every position in the x axis, starting at 0, we're iterating over all the y. So we start at 0, x, and then we go y 0, 1, 2, 3, and then we move on to the next x, which is 1, and then we go y 0, 1, 2, 3, all the way until we finish. Okay, so what we're going to do is we're going to get our current tile. So we're going to say transform current tile equals grid, and the index in that multi-dimensional array will use the x and y values. So that'll be our current tile. That's the tile that we're currently at. Okay. So transform, we're going to create two more. We're going to create a tile below, and we are going to create a tile beside. Oops. Transform tile beside, and we're going to set that equal to null as well. Alright, so we're going to say if y doesn't equal 0, then tile below equals grid x, y minus 1. And then we're going to do if x doesn't equal grid width minus 1, then tile beside equals grid x plus 1 y. And I'm not saying y do this, I'm saying y. And grid width, that's wrong, grid width has got a d in it. Okay, so what we're doing here is we're checking to see if y doesn't equal 0, right? So if y doesn't equal 0, then y is 1. Okay? So, and if y is 1, then our tile below is going to be y minus 1. We can't check for a tile that is lower than 0. So let's say that y is at the 0 position. We can't set tile below to anything because what will happen is we'll get an index out of range error. And that's not going to be pretty, and we don't want those. With x, it's the same thing. We're going to say, hey, does x, if it's not equal to the grid width minus 1, which the grid width is 4, but remember we're starting at 0. And so x starts at 0, which means we only go to 3. So we check grid width minus 1, which actually equals 3. So if it doesn't equal 3, if x doesn't equal 3, then the tile beside equals grid x plus 1. So if x is currently not 3, and let's say x is 0, then our tile beside, right, the tile that's beside the one that we're currently checking is going to be the one that's next to our current x location. So x plus 1, which will be 1. So tile beside is going to be a transform that we're going to assign from grid x plus 1. So let's just assume here that we're at 0, 0, okay? 0, 0. So what we can do is we can say if y doesn't equal 0, then tile below equals grid x, and then y minus 1, which means at this point, y, or our tile below, is going to remain null because we're at 0 for the y. And x, let's see, x doesn't equal grid width minus 1. Grid width equals 4. Minus 1 equals 3. And x doesn't equal 3, which is true because x equals 0. So that means we're going to assign a tile to tile beside. And the tile that we're going to assign is x plus 1. So x right now is 0. We're adding 1. So our index is going to be 1, y. So y is 0, so the tile that we're going to grab is 1, 0. At location 1, 0. We're at location 0, 0. We're going to grab 1, 0. So we're going to grab the tile that is beside our current tile. Okay? Hope that makes sense. I do my best to explain these things. Okay. So, let's move on. So now we're going to check. If tile beside doesn't equal null. Alright, so first we check to see, hey, does our tile beside equal null? If it doesn't, then we have to check something. We have to say if current tile dot get component tile dot tile value, because remember we're storing the actual value of the tile. If it equals tile beside dot get component tile dot tile value, then what we do is we return false. Okay, and we're returning false because the current tile, remember, which is at 0, 0, is actually equal to the tile that's beside it at 1, 0. So they must be either both 2s or both 4s or both 8s. And if those two are equal, then we want to return false for our game over, saying that no, it's not game over because there are still two tiles that can be matched if the user presses left or right. So then we check if tile beside or tile below isn't null. If current tile dot get component tile value equals tile below dot get component tile dot tile value, then we return false. Alright, so same thing, and since tile below at this point in our iteration of our for loops is equal to 0, that means that tile below didn't get assigned, so tile below is null. So if tile below doesn't equal null, then this runs. If tile below does equal null, then nothing happens here. Okay? So at the very end, what we'll do is we will return true. So if nothing else happens, okay, so if this isn't true, if this isn't true, and if this isn't true, then we've done all of our checks to see if there can be a game over, and we have determined that there is no way that the player can make any more moves. Then we just return true here, because all of these checks returned true, or false, sorry. All of these returned false, and not returned false, but all of these actually, all of the checks that these have done have been false. So like for instance, current tile, that tile value equals the tile beside that tile value. Okay, so let's say that that's false. If it's false, then it's not going to do this. It's not going to return false. It's just going to go to the next one, and then it's going to check, hey, does this value equal that value? No, it does not. So we don't return false again. So at this point, we've done all of these, so we iterate over the for loop again. So now we're at the next position. We check all of these, we check all of this again. Doesn't return false, we go back through the for loop, and around and around and around. We go all the way through all of the indexes, and once we hit the end, you know, if these didn't return, and by the way, what happens is when you return a value from a function that has a return type, what will happen is it'll break out of that function and nothing else will run. It'll just return false and end there. It will not run again. It'll not continue to run the for loop. So the for loop's done. Once you return something, you're done with that function. It's complete. It's finished. So what happens is these for loops run, and if we don't ever return false here, then the next line of code will be executed, which is this. So obviously return true. Alright? So that's that. What we have to do now is we actually have to call this. And the best place to call that, of course, is in here, in our update method. So we go check user, or check game over. And there we go. So now, let's just output something into our debug window so that we can see whether or not we've got a game over. So debug, add, oops, oh man, I messed that up. The game is over. No. This is the label. Check game over. And then the value that I'm just going to use here, I'm just going to call it true. So, actually what we'll do is, let's do it this way. Check game over. So, we will add this in. In order to do this, we're going to have to add brackets. So we're going to return false here, and we're going to set our debug to false. And what is going on here? What am I not seeing? I don't know. Frigging Visual Studio is being weird. Alright. So, same thing here. We're gonna add these. And we're just gonna copy here. And we can be a little more descriptive even. And we can say false tile below and false tile beside, and then we can say false false empty spaces, because obviously there are still empty spaces here when we do this. And then finally debug add check game over true, and check game over. Alright, so that's that. So now we'll save that and go into Unity, and let's stop our game and start our game. Now we're gonna have to get that game over again, and I see I have a thing here that I need to fix. Alright, so right now it's telling us false empty spaces, which means that we've got plenty of open spaces. So let's try to reduce the amount of open spaces. So right now it's telling us that we have a tile beside, and if you look, you can see that that's because that there is a 2 and a 2. So now I'm going to move these over one, and now it's saying there's still a tile beside. So let's do this again. Let's move these over, and let's move these over. We've got empty spaces now, more empty spaces, and we've got a tile beside, empty spaces, tile beside, empty spaces, tile beside, empty spaces, tile beside, empty spaces, true. Alright, so now our check game over is true. We have no more moves left. So that worked exactly how we wanted it to, huh? How cool is that? So there's one more thing. We can still press buttons. And that's not really a big deal. But what we can do is we can limit that. Since we are returning since we're returning false or true, depending on whether or not the game is over, we can limit user input based on the value returned from game over. So what we can do here is we can write a little if statement in our update method. So we can say if not check game over, and that's not saying, hey, we're not checking check game over. We're basically saying, hey, what's the return value of game over? If it's not true, then do this. So we could rewrite this as check game over does not equal true. But that's just making things difficult. If check game over does not equal true. Another way you could do this is you could create a boolean. You could say boolean is game over, and you can set it equal to check game over, and then you can take that variable and you can validate that here, and you can just say if not is game over. Okay, or again you could say if is game over does not equal true. So there's many different ways to write this. I like to be as efficient as possible. So we are just going to delete that, and we're going to write if not check game over. Okay, so if it's not game over, then we check user input. Simple, right? So we delete that here. Okay, so if not check game over, meaning that we're returning false from check game over, meaning that we don't have a game over, then we check for user input. If this happens to be true, then this will never be called. Okay, so if we have a game over, this will never be called again. Cool, right? So, well, that's it. I mean, for this tutorial, the next one, we're actually going to talk about the HUD and implementing that. So that's going to give us some more visual feedback as to whether or not we have a game over, what our score is. We're going to add some like scoring things. So the next one will be kind of fun to make it better. The video after that is going to be really cool because we're going to add in animations and sounds to make the game pop, like just to make it look way better than what it is right now. Right now it's a functional game. But we're going to make it a pretty functional game. Not a pretty functional game, but a beautiful functional game. Pretty beautiful functioning game. A damn good freaking game. Okay, so again, the end of the video. I hope you guys enjoyed it. I hope you learned something. If you have questions, feel free to ask me. I do my best to respond. Sometimes I don't get back to you guys right away. Sometimes I like take way too long to get back to you guys, and then you forget all about me, and then you hate me, and then you unsubscribe. I don't know. But anyways, I will do my best to respond to you. If you like the video, give me a thumbs up. Don't forget to subscribe, click the bell, invite your friends. Oh, and videos every Saturday now, okay? I am the Weekly Coder, and every Saturday I'm going to post a new video. So I'll see you guys next time.